Welcome back, viewers. So this series of lecture on machine learning models and explainable AI. In this lecture series, we were seeing certain number of SHAP plots. SHAP is your explainable AI library. It is predominantly used for analyzing the features importance and features impact on the model outcome, the AI centric model outcome. So, in this lecture, we will see more of this SHAP plots. So, decision SHAP plot is one of the plots that is used for doing the decision making in the SHAP environment. So, SHAP plot, when we are doing a decision making, the line plot is more used in this particular aspect, where each of the line is denoting each of the features. So, it is starting from the base value and gradually moving upward to the final value, that is the final model outcome. So, this decision SHAP plot, it centers basically on the expected value. Expected value is the mathematically expected value, that is what we are referring here. It is on the x axis, and with relative SHAP values, as we move upward, the SHAP values of each of the features, they are you can say they are being connected with the line. So, you get this kind of a rising plot. And the decision plot is again it's a kind of a summary plot, because you can see a number of lines over here. So, each line refers to a particular sample. So, the number of samples you have, you can have the number of lines on the decision SHAP plot. Now, though it looks very messy, as you can not at I mean you cannot identify how a particular line is behaving in the decision SHAP plot. So, later we will see that how a particular line, if you want to see how it is escalating from expected value towards the predicted value, we can also make, or you can say you can modify this decision SHAP plot in a manner that from the summary mode it can shift to the instance mode. Okay. So, one utility of decision plot is that it can be falling into the category of the summary plot, also in the category of the instance plot, that is instance level information also it can cater. But even if the graph looks messy with the the lines, multiple lines in the same plot, but at least you can have a overview of the trend of the different features, whether they are imparting more towards the negative axis or the positive axis. So, whatever prediction you are getting, it is a lower prediction or a higher prediction, this can be drawn down, this particular conclusion from the decision SHAP plots. Another one is the heat map SHAP plot. So, this is also again a summary SHAP plot belonging to the summary category. So, for this particular plot, the data set is a little bit different. The data set describes about income of people. So, there are different aspects, different features that may drive towards a higher income or a lower income. So, there could be some people with multiple family responsibilities. So, if the responsibilities are more as per the given data set, we can see that the first feature, relationship, it is showing that if a person is having lot of family responsibilities, then there is a higher likelihood that he will look for a job with better prospects, because he has to cater to multiple responsibilities. So, according to the data, according to the records that we have in this particular data set, the heat map SHAP plot is given. Also, there are different other features, like with age, the income from high to low can be distributed. Then there are capital gains, there are so many other occupations, and the gender based analysis if you want to do that, also you can get an idea from the heat map analysis. Next is the model instance shape plot. So far we were seeing the model summary shape plots. So now we will see from the instance level what kind of information we can provide to the end user. So these shape plots, once again, they are helpful not only to the domain specific experts or the programmers, but also these are very much useful to a layman. That is, if the end user is not a domain specific expert or maybe is not an expert programmer, still looking at the shape plots, the person will be able to understand why the model has given the prediction in a particular manner. So, in this category of instance level shape plots, the first one is the waterfall shape plot. So, this plot provides a breakdown of the prediction. Again, it uses the expected value to start with from the very base, or you can also call it as the base value in this case. So, and you can see that it starts from the base value, and there is a arrow kind of a bar. So, it's a bar plot, but it's a arrow bar plot. So, it is signifying the direction also, that whether it is towards positive or towards a negative impact. Okay. So, here it is more of like a waterfall, and also it gives you the significance, the it helps you to understand whether the particular set of features are giving a positive or the negative impact. Okay. So, maximum of the features we can see that it is towards a positive, it is giving a positive impact, and hence you are getting a value on the top corner in the right hand side. That is the value of fx, which is depicting the model prediction or the model outcome. So, there are different colors also that you might have seen in this plot. These are just for distinguishing the negative and the positive contributions. Next is the force shape plot. So, force shape plot, it depicts the direction and the magnitude. So, not just the direction, if I want a plot in which the direction and magnitude of the impact of the features, I want both the things in a same graph, then this is the best plot that the people can use, where the direction and magnitude of each of the feature contribution can be portrayed. So, why it is called a force? Because it is actually pushing some of the features that are on the higher side, they are pushing the prediction towards a larger value, and the features that are having a negative impact, it is lowering the chances. So, there are some red features and the blue features. So, red features are nothing but they are increasing more towards the positive value, and the blue features are lowering the chances. Now, this data set is actually it's having the reviews of some product or some movies or anything. Okay. So, it is basically a text based input, you can say. So, whether you are getting a positive review or a negative review, and for a positive review which features are responsible, that you can easily see from these particular graph. That is the shape plot with the force of each of the features towards the prediction. Okay. And also, if we have a multi-output prediction model, in that case also it is very helpful. So, not only just for the you can say the binary classification, but also for multi classification, multi-class classification, and also for the multi-output model prediction, this particular force shape plot can be very, very helpful. Now, if we can quickly understand about the multi-class, binary class and multi-output model predictions. So, binary class, it's very clear that binary class, what happens that you have two classes in the target variable. If you have more than two classes in the target variable, then it becomes a multi-class classification problem. And if you have multiple target variables, okay, so it's in the binary and in the multi-class classification problem, there was only one target. But what if you are having multiple targets in the first place? Then it becomes your multi-output model prediction. The figure shows this sharp plot. This particular figure, it shows for the data set that we have seen so far, and you can see that what is the higher side and the lower side of the impact on the pH prediction. Next one is the decision instance sharp plot. So, we have earlier seen decision sharp plot with the help of the summary, how the model summary works. So, we have seen it from the perspective of a summarized sharp plot. Now, we can see it from the viewpoint of a instance sharp plot. So, this is a sharp plot where the individual, how individual person is drawing income from their offices. So, this is that particular data set, and to understand, or you can say to model this data, we have used light GBM machine learning model. So, the data is first trained with light GBM model, and then this trained model is used for making the sharp plots or the sharp decisions. So, in this decision plot, you can see that there are again multiple line plots, but if you want to pick one line out of this particular decision plot, then the decision space becomes reduced. So, it can have one or two or very few numbers of lines. So, there could be some misclassifications in the models. So, misclassifications are what? It means that we have some ground truth reality, that is we have some target variable that we have to predict, but also for that target variable we have some sample instances. So, for whatever prediction we are doing, maybe the predicted value is not matching with the actual value that is there in the test cases, or you can say the test data set. Okay. So, when we actually do the machine learning training, we divide it into train and test data sets. So, we will look more into this in some other lecture, but just for the time being you can understand it in this way, that we can find out the misclassifications where the prediction and the actual value in the test data set is not matching. We want to see that why that kind of misclassification happened during the model building or the model testing. So, for that decision the decision plots can be seen from the perspective of the instance. So, in the instance level you can highlight the misclassified line, and each line we know once again that it represents a specific sample. So, the sample could be in this case it is a person who is earning, okay, and we want to predict the models, how the model is giving the outcome. So, in this case what we can do is first we find out the point, or the you can say the sample that is being misclassified by doing this equation, misclassified equal to the y predicted or the y predict that is not equal to the y test, and it could be the data frame or whatever data you are referring to. So, now the misclassified instance is there in this particular variable, that is in the L value side misclassified, and then we use this option highlight equal to misclassified. So, we are highlighting it using the dotted lines. So, even if we have more lines and we want to highlight, we can do it like this way. So, the sharp decision plot, when it is seen from the perspective of instance plot, how we do it? We use this particular code snippet, that is having the expected value, the sharp values, the features display, and the link, what kind of function is being used, logit function is used in this case, and highlight the misclassified sample. So, you get this line which shows that due to certain spikes that we can observe here, the data was misclassified to a wrong class. So, this kind of data actually becomes very useful when you are, this plots can help you out to understand or to analyze deeper into why prediction happened. Next case study is with the sharp plots specifically for the multi-class classification problem. So, just now we were talking about that there are certain classification problems where you can have a single target, but that target can have multiple classes, not two, but more than two classes. So, this is one data set, it's a crop data set where you have certain parameters, the nitrogen, phosphorus, potassium, temperature, humidity, pH value, rainfall and all. And given these parameters, maybe the agriculturists, they want to know that which crop to invest at a particular season or time of the year. So, if we have the crop data set like this, and we can have different classifiers also on the same data set, and we can have the all sorts of performance evaluation metrics like the accuracy, precision, recall, and all those things. And in the vertical you can say in the vertical column, the first vertical column, you can see that there are different types of crops. So, rice, maize, soybeans. So, like this the different crops are there. So, all these crops are actually the classes. So, you can see multiple classes are there, and for each class the performance analysis is performed. So, and whole of the study is done using two classifiers, the random forest and the SVC, that is the support vector classifier. Okay. So, for both the models, we will see that how for multi-class classification problem, explainable AI can be helpful. So, this is the feature sharp plot. So, this is a feature importance plot that we have seen earlier. So, in the feature importance, we can see that which features are most important. Okay. So, now in this kind of plot, when there is multiple classes, we can see for each of the class what was the contribution of a particular feature. So, each feature are contributing differently to the classes. Now, for individual class, when it comes to the random forest classifier RFC or SVC, it is a little bit different. So, obviously it can be different as SVC and RFC are two different classifiers. So, you can also conduct another classifier or few more classifiers, and you can do a good comparison between the what the feature importance is when we are training the model using different classifiers. And not only just the different classifiers, but here we can also see the outcome, multiple outcomes with respect to the multiple features, or you can say not only just multiple features, but also in this case we have multiple classes in a single target column. Now, there can be some text data also. So, as far as whatever case studies we have seen, we have mostly on the numerical data. So, what if we have some text data? It could be the feedback data, or maybe someone has posted something on the social media and we want to analyze the sentiment. For that, the very essential steps are, first we load the data set. But again, in this case, we are using one of the inbuilt SHAP data set. So that's why it is SHAP.dataset, and it's a IMDb data that is being loaded, what is the feedback of the people for different kinds of movies and all. So, for this, again, as I was just saying some times back, that whatever the data is, whether it's a numeric data or text based data, you have to segregate it into a training and a testing data set. And then whatever data comes out, then you vectorize it. So, vectorizer is used in this case because it's a NLP kind of data, that is text kind of data that requires natural language processing. So, vectorizer helps you to extract the important words or you can say the tokens from the text material, and then you can do the X string and X test, that is you are fitting the model, and finally when the model is built, then you can analyze the performance using the XAI models. So, if now we can see the XAI once the model is built and the explainer is used again as we have done earlier also. So, here the model is passed and the X train features is given, and now you can see this plot which shows that there are certain words, that is more towards the negative aspect and more towards the positive aspect. So, if it's best, great, so they are all towards higher value of positive. It's if it is worst, bad, then it is moving towards the negative axis. And obviously there could be some values that are of less importance, and hence they have got cluttered at the base. So you can do a little bit of data pre-processing and remove these unwanted values. Next is the image data set. So, we have seen the numeric data set, the text data set, now image data set. For the image data set, there can be image input. So, again in this case we are using inbuilt data sets from SHAP library. So, whenever we are loading a data set and we want to see the output, so it could be different cases, like whether it is a segmentation problem or some kind of recommendation problem. So, in this case you have taken a masker. Okay. So, we define the masker that is used to mask out the partitions. So, accordingly we train the model, and then we use the explainer. So, the explainer, what it is doing is it is showing the what kind of the picture can be classified as. So, is it rightly classifying as a particular bird or a particular animal or something, or it could be any object also. So, you can analyze these kind of data sets as a further study, and you can see that when you are applying different maskers or any different models, depends upon what kind of problem you are defining, and then for each of the problem you can analyze that which model, applying which model is giving you better accuracy or better visibility or better recognition of a object. So, not just with the text data and with the this numeric data, but also with the image data you can make use of the SHAP models. Now, similar to SHAP, there is another model, that is the LIME model. So, LIME model is another XAI model, or you can say a tool basically, that can be used for showing some explainability information, just that the interface would be different. So, say we have diabetes data set from Kaggle. Kaggle is nothing but a repository of a very good repository of the data, and there are many more other repositories like Kaggle. You have GitHub, okay, you have Snap for network data, and so many other repositories are there. So we have taken this diabetes data set from Kaggle, and a simple RFC classifier is used, that is the random forest classifier. And now instead of using SHAP, now we will use LIME. So let's see that how LIME can explain or give explanation to model outcome. So the how this LIME shows the information is actually can be defined in three ways. It gives the model prediction, the feature contributions, and also the actual values for each feature. So it's giving a summary value also, it's giving the final model outcome also, and the feature contribution. So all in one interface. So far we have seen SHAP with different types of plots, but in this particular LIME plot you will see that one plot is conveying three different things. So we can observe from the plot in the figure that if you want to see that how many people are having diabetes or no diabetes. So it is the model outcome is being shown, that how many yes diabetes are there, how many people are not having the diabetes, and then in the middle there is this class. It's there are these two classes with has diabetes or has no diabetes. So these are the two classes. So basically this is a binary problem. So here you can see that there are some features that are clearly lying towards has diabetes, and there are certain features that may not affect much to find out whether the person is having diabetes or not. So they are not the driving factors to analyze. So this model is giving the output that the patient is predicted to be diabetes. For a particular instance, a patient is predicted to be diabetes with 72% of confidence. Why? Because two most important feature was indicating towards having the diabetic problem. And also you can see the feature and the values. So this is very much similar to the SHAP importance plot, right? And the reasons is very clear, because these two that are very important features, they are towards this class of yes diabetes or having diabetes. So that's why we are getting the this kind of plot. So this is a very integrated plot where you have multiple information portrayed in a single screen. So it's your choice that which model to take. There is ELI 5 also, explain me like I am 5. So these some of these models are there. So what is the criticality of your problem? How much depth your problem space needs to be analyzed? All these things, they are the driving factors for you to choose the right XAI model, the explainability model. So through the lectures so far, we have seen the SHAP and the LIME models. So you can also try other models as well. So each of these models, they have their individual library and documentation. So for SHAP, if you see the SHAP documentation, it's all about the SHAP, different aspects of SHAP, and LIME also likewise having a different documentation. So I hope this lecture will be very helpful for you to understand how the machine learning models behave, because more often we design the model and get the outcome as accuracy or precision, and we end our research. But with the SHAP models, with the LIME models, that is with any XAI model, you can go a little bit further beyond the accuracy and precision and other performance metrics, and you can see that why the prediction is coming. So it is something like AI over AI, that is AI for the predictive analytics, that is given by the AI model itself. So it's a very interesting area to research further, and these are the further study references, because since this area is very fresh, is very booming area, so the research papers are ideal reference materials to go through. So I hope you have all enjoyed, and let's meet again with a new session. Thank you.